Hi, in this video we're going to learn how to solve logarithmic equations. At the end of the video, you should be able to solve logarithmic equations. Let's start with things you need to remember. In an expression logarithm base b of y is equal to x, b is called base, y is called argument, and x is actually exponent. Always remember also you can use your power table, which helps you find powers of a number given a special number, which are your problems involved in exponential equations and logarithmic equations. Without calculator, you are able to figure out powers of a number given as a special number with the help of a power table. Now let's have the definitions. First definition here, if b and y are positive where b is not equal to 1, then the logarithm base b of y is defined as logarithm base b of y is equal to x if and only if b raised to x is equal to y. This definition is saying that given a logarithmic equations, we can convert it into exponential form and apply the steps in solving exponential equations to find the value of the variable. There's one more property, it's called one-to-one property. It says if logarithm base b of x is equal to logarithm base b of y, if you notice they have the same logarithm and base, then we can actually solve it by just equating argument x is equal to argument y. Just remember, it's called one-to-one property. If you are given the same logarithm base on both sides, you just equate the argument on the right side, the left side, equals to the argument on the right side. Now, consider that there are actually 4 cases of solving logarithmic equations, which are the simplest form. There can be complicated cases of logarithmic equations. Let's consider 4 cases of simple logarithmic equations. This is the first case wherein the unknown is your exponent. Second case, the unknown is your argument. Case 3, the unknown is the base. You're going to look for the base value. The fourth case is the case that involves one-to-one property. Given a logarithm of the same base on both sides, you just simply write argument x is equal to argument y to solve the equation. Let's have the first example, which is case 1. Evaluate the expression logarithm base 2 of 32 is equal to x. Given that logarithm equation, the first thing you can do is rewrite it in exponential form. Convert to exponential equation. It's 2 raised to x is equal to 32. How do you proceed? Well, you need your power table because you are now going to find like base and solve for x. To make them like base, 32 should be converted into 2 raised to 5. And it's done. Since we already have like base, you just cancel like base and you found your x. X is equal to 5. And this is the case 1 example. Let's have the second case. This time, you have the unknown argument. Evaluate the expression logarithm base 8 of x is equal to 3. Copy your given. To solve, you need to rewrite it in exponential form. You have 8 raised to 3 is equal to x. Actually, it's easier. It's quite obvious that what you need to do is to perform the exponent. 8 raised to 3 is 8 times 8 times 8. And you're done. X is equal to 512. That is the case 2 where the argument is unknown. Of course, the problem will get complicated if there are fractions involved, but the flow of work is the same. Let's have the case 3 example. This time, the unknown is the base. Evaluate the expression logarithm base x of 128 is equal to 7. Copy your problem, convert to exponential equation. You have x raised to 7 is equal to 128. From your lessons on radicals, to find x, we do the opposite. Since this is power of 7, the opposite of power of 7 is root, 7th root. We are going to perform radical on both sides. So, to do that, we are going to find 7th root of both sides. Here it is. 7th root of x raised to 7, 7th root of 128. Again, this time your power table is again going to be helpful. Just look at your row where you find 128 and see which root does it have. It's the first column. Actually, the 7th root of 128 is 2. 7th root cancels out because it's opposite of power of 7. So you have your answer, x is equal to 2. And that's your example of case 3. Let's have example number 4. This time it's your case that involves one-to-one property. Very easy. To do that, you copy your problem. You don't rewrite into exponential form. Instead, you are going to write argument on the right side is equal to argument on the left side. Argument on the left side equals argument on the right side. And then so, divide both sides by 2. 12 divided by 2 is 6. 2 is cancelled on the left side. And so x is found. That is the case 4 that involves one-to-one property. It's only possible if you have exactly the same base. Otherwise, it's going to be special cases other than this one. Let's have another example of the case 4. It can get complicated. Check this out. You have evaluate the expression logarithm base 4 of 5x is equal to logarithm base 4 of x squared plus 6. To begin, copy your problem, write your equation of argument. 5x is equal to x squared plus 6. This is your equation of the argument. And then, since you should know this, you have square. This is going to be a quadratic equation. You need to write it in standard form. To do that, we are going to subtract both sides by 5x so that this becomes 0. 5x appears in the middle of x squared plus 6 as negative 5. There are many ways to solve your quadratic equation. Of course, you can do graphing, you can do factoring, or you can do the quadratic formula. Since the problem is not that hard, we can perform factoring. Factor 6, there's no other. You have 3 times 2. Since the middle term is negative, it means 3 times 2 is positive 6, but when you add, you get positive 5. To get negative 5x, the factors are supposed to be negative 3 and negative 2. Anyway, negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 gives you negative 5, so that will be the correct factor. Perform your factoring, and then you have x is equal to perform factoring and then your zero factor property. So what are the factors of 6? 6 has a factors of 3 times 2. But when you add, you have negative 5. To come up with a negative 5, we can make 3 and 2 negative. So anyway, negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. So that should be your correct factor. The zero factor property is saying we will equate both factors into 0. X minus 2 is equal to 0. X minus 3 is equal to 0. So therefore, if x minus 2 is equal to 0, therefore x is equal to positive 2. X minus 3 is equal to 0. X will be actually positive 3. So there are two possible solutions for this problem. X can be positive 2 and x can also be positive 3 to make the problem or the equation true. And that's how you solve, and they are actually the simple cases of logarithmic equations. There are complicated cases which we will deal on the next lesson. You should have learned how to solve logarithmic equations given the following 4 cases as explained. You may watch the video again if you need to. Thank you.